Yes, thanks, Pierre, and welcome everyone to this webinar. Let me just first introduce myself a bit for the people that don't know me, and I know already that a lot of people that know me are in the audience, so that's good. My main occupation is that I'm a principal consultant at IDC METRI, but already for a lot of years I'm also involved in Nesma and in ISBSG, and I'm going to introduce also Nesma and ISBSG a bit for the people that don't know these organizations. And my main expertise is all kinds of management consulting about, well, let's say application development and maintenance and support activities based on functional size and data. Like the things that are here: agile value management, agile team performance measurement, software cost estimation, output-based contracting, those type of activities that we do as IT intelligence services of IDC METRI, and that are supported by for instance, Nesma with the functional sizing, the cost estimation practice, but also ISBSG data. And I'm going to show today a bit about, first of all, the organizations, also about the ISBSG data, and also a few practical cases that I worked on last 2 years, I guess, where I used both functional size and ISBSG to make a real difference for the customers. And if you want to reach me, my email address is just here, so you can send me a message. It's maybe important to understand that this webinar, we are presenting this on behalf of both ISBSG and Nesma, so it's not an IDC webinar or anything. And I know just the light switch on, so someone is in the office here. It's not a problem. So today we're going to talk about a brief introduction of ISBSG and Nesma for the people that are in this webinar and who don't know these organizations. I'm going to talk a bit about the importance of functional size measurement, because this is usually also something that I have to explain to our customers, that there is a way out there that you can measure size of software, and it is standardized and you can use it, and there are all kinds, if you do that, there are all kinds of advantages. Then the ISBSG data, how does it look like? What can we do with it? And a few practical cases I just explained. So this is basically the topic of today. I think it's going to be a bit longer than half an hour, so I hope you have some time longer than half an hour. Let's just first start with ISBSG and Nesma. So ISBSG is already around for more than 20 years. It started as an organization because in Australia, it's still based in Australia, because in Australia there was a movement, what was called at the time the Southern Scope project management, and in the Victorian government, where functional size measurement was used to make project management type of decisions on scope. And at that time, they also thought, okay, we have functional size, but we don't have data, so we should have an organization that's going to collect data. And ISBSG was founded together with a number of measurement organizations, like IFPUG, like Nesma, like ISBSG, and a number of those. To measure or to collect the data worldwide about software projects and maintenance and support. While Nesma is one of the ISO standards for functional size measurement, as you may know, you have IFPUG, you have Cosmic, you have Nesma. Those are the three most popular standards worldwide. And if you look in the ISBSG data, and I will show you later, these three measurement methods are really dominant also in the data. So there's a lot of data in the ISBSG data that are measured, projects measured in IFPUG, in Nesma, or in Cosmic. Nesma is mainly known about its functional size standard, but also because of the cost estimations of cost estimation activities. There's a lot of materials there as well. Just to have a few more words about ISBSG. So the mission stands here. So ISBSG is a not-for-profit that tries to improve the industry by giving the data, providing the data to make better decisions this is basically what we do. So we collect the data in ISBSG and we provide it to the market, say, okay, this is data, it's standardized, it's verified, it's recent, you can use it to make better decisions, maybe estimation, maybe performance measurement, maybe outsourcing. There are many use cases where you can use the data. It's important to understand that it's independent, and the data is all standardized and verified, so you can use it with a good feeling. At the moment, there are over 11,000 projects, releases, sprints in the new development and enhancements repository. And there's another repository, it's maintenance and support, which has data of over 1,100 applications at the moment. And what not everybody knows, but what's important is that ISBSG is collecting data from the industry, but everyone can submit the data. So I have also here a link to the submission page. There are several questionnaires there. There are short questionnaires, long questionnaires. It just depends on how much data you have of your project. But the good thing is that you get, if you submit your data, you will get for free a benchmark report of your project or of your maintenance and support activities that shows you how you performed against industry averages. Like you see here on the right, you see two graphs where you can see a bit of a benchmark of a certain project against the data in the ISBSG. And of course, we really looking for as many submissions as possible, which also helps, let's say, the members. In Nesma, for instance, if a Nesma member submits data to ISBSG, that will also help Nesma and it will help ISBSG in some way. Okay, well, if we talk about Nesma, it is, like I said, it's about measuring functional size. It's also about being a community, getting people to talk about functional size measurement, using the measurement methods, connect to each other, network, etc. And also about cost estimation. And here you see on the right also the Nesma accounting guidelines book that is used a lot in the industry. It's available in Dutch, English, Chinese, physical, digital. And there are all the accounting guidelines that you can use to really size the functional size of a project or of an application. Yeah, so Nesma metrics and more. So this is just the website that you can go to. Okay, so that's a bit of introduction about ISBSG and Nesma. And then I know there are many people here that know the importance of functional size measurement, but I always have to prepare that there are people that here that don't know about it. So I have to explain that a bit more. And I was a bit puzzled because I come across these type of things on Twitter. So someone says, okay, there's an asteroid flying to Earth and it's the size of 14 flamingos. And then you think, okay, but what is a flamingo, right? So I just looked it up. Okay, there are like many different sizes of flamingos. And so the point is that if you make just a message, but there's no way to really accurately size it or to understand how large is something, it becomes meaningless, and you can't really use data, or you can't really use that for any decision making. And of course, this is what we often see in the industry, especially now in the Agile days, where teams usually use the story point metrics, story points for estimation of work, which probably we all know is pretty useless if you want to use that for management information or outside of the team itself. And it's basically kind of similar thing. So you assign some point to something, and then you just try to figure out how much work something else is relatively to that thing. And there's nothing wrong with that on a team level, but of course for real decision making on a higher level, where you have multiple teams, you have multiple epics, multiple various streams that you have to work on, that's kind of useless to use those type of metrics. So you need something that is standardized. Why wouldn't we use the square or the cubic feet or meter or whatever volumetric standardized volumetric you would use to show how big is the asteroid here. But the problem, of course, is that we're talking about software, we're talking about functionality, and it's hard to measure because in the end, when software is ready, of course, you can measure the lines of code, and even that is probably not that useful because more lines of code doesn't really mean more functionality or anything. But at least at that point, there is something there that you can measure. But for instance, if we're talking about cost estimation, you need to do that earlier, of course, not when the project is finished. The cost estimation uses that in the beginning of the project. You need to understand, okay, this is the cost. It's going to these are the benefits. This is my business case. And people think that's hard. People that are not in this community of Nesma, of IFPUG, of Cosmic. A lot of organizations out there that just use expert opinions about, okay, how big is it, how much work is it. There are even people that think, okay, it's so hard to estimate that we should maybe not even do it. The hashtag no estimates community, if you look on Twitter or LinkedIn and you Google for hashtag no estimates, you'll find many people, many conversations, discussions of people that just think, okay, software projects just too hard to manage, too hard to estimate. Let's just not do it and just start and just see where it all ends. Which, of course, I don't have to tell you that is not a very good practice because that will, can lead to real slippage of cost, of overruns of all kinds of stuff. Just like you wouldn't ask your construction company to build your house without any estimate of how much it's going to cost. This is also, of course, for software projects. In the end, there's always someone who's going to pay for it, and he would be willing to have an accurate estimate first before you start. And this is a slide that I also like to show because it's a maturity model for cost estimation, and cost estimation is an important activity in the industry. Many projects are starting, even in the agile world. You still need to understand how much something is going to cost when your, for instance, your minimal viable product is ready. And this model is constructed by Garrett. It's already out there for quite some time. And the important part here is that there are several levels of maturity. And you see from the industry, the most used methods are the human judgment methods, which are level 0 and 1. It's just asking people, maybe one, maybe multiple people, okay, this is the project. How much do you think it's going to cost? I don't know, for design, for test, for developing, and put it in a spreadsheet, make some WBS, try to figure out, okay, maybe there's a bit of contingency, a bit of risk, and that's your estimate. And these are usually very much biased because humans usually are very much optimistic. And you see also from level 2 onwards, there is a very important part, which is the sizing first. So you need first to understand what are we talking about? How big is this thing that we have to develop? And only then we're going to try to figure out, okay, it's this big, how much effort would it cost to make it? And it's much more unbiased because you can rely on data then and not on expert opinions of people who are biased. Let me just first go into the size a bit more, because a lot of people always ask me, okay, with function points, how does it work? And we're working agile, so we can't use function points. This is something that we did in waterfall times, etc. But in fact, if you look at how the method works, it's basically you have users that interact in some way with data. And there are a few things that are here. So you have the data in the database, you have data in other systems, and you have users interacting with the data by adding or modifying or deleting data. or by extracting data to get on the screen or on your printer. It's basic interaction between users and information systems. And there are a lot of counting guidelines out there that if you want to do a detailed method, you will figure out how many function points are there. So in this guidelines, it just says, okay, whenever you have this thing, there are all kinds of rules that say, okay, we have an ILF, it's either simple or average or complex. A lot of rules for certified guys to figure out, okay, we have customer, it's an ILF, okay, is it easy, is it medium or complex? But in the end, you get only 7 or 10 or 15 points for that, for any ILF, for instance. So that means that even though that there are a lot of rules that you have to know as a certified person, there are also higher level methods that you can more easily use if you don't have all the knowledge of this book and you are not certified. You can still use these methods because, for instance, if you have a data model and you only know your objects, let's say the entities that are there that you have to develop in the end, you can use this indicative function points. This is the Nesma method. And you can just see, okay, I have a conceptual data model, or it's already normalized, and I have a bunch of objects there, and I just multiply them by 35 or by 25. And you can see here, there's a study here of detailed function points against this high level. Okay, it's not completely accurate, but this is the thing you can use already very early in your project lifecycle. And then you already get quite a good indication that you can use for your business case and for your estimate. If you have a bit more information, you can use the higher level function points. This is the estimated function points that is in the accounting standard as well. You just figure out, okay, which data do I have, which transactions do I have, and then we have this fixed numbers. So in a detailed account, you would really have a lot of rules that say, okay, either is it simple or average or complex, and then you assign the points. But here you say, okay, I have an ILF, I just put 7 points there. I have an EL, okay, it's just 5 points, without considering all the rules that are there. And in the end, this also works. You can see here, it works quite well. Why? Because you see here for EO, for instance, you get either 4, 5, or 7 points. So you can spend a lot of time figuring out if it should be 4, 5, or 7. But if you take 5, it's like in the middle. In the end, you will be very much quicker, and it will pay out because it's quite accurate to do it like that.
Harold,
yeah.
Harold, we just got a question. Please explain the difference between ILF and EIF.
Okay, yeah, I can do that. It's not really part of the presentation. So ILF are let's say the objects that are inside of your application that you're measuring. For instance, you are measuring an ERP, which is installed on your infrastructure, and customer, or let's say CRM. It's a CRM. And customer would be one of the ILFs, because this is the thing that you can add. You can add customers, you can modify customers, you can delete customers in your system. So customer would be an ILF. But for instance, if you enter let's say the postal code and the house number of a customer, and it fetches the information of another system, maybe some other system that stores data about addresses and locations. So you fetch information from another system, not the system that you're working on, but some other system. Then that would be an EIF in IFPUG terms, or ELF, external logical file for Nesma terms. So you use it, but you can't modify anything in that. You can't add the data there, you can modify, you can delete it. So that's the main difference between ILF and ELF. I hope that's helpful. And I'm still here in the part where I try to explain why sizing is so important. Because if you go like this is like the level 0 and 1 estimation, for instance, right? So you go directly from your scope, whatever is in your document, to the effort and the cost. But once you first go measure the size and then the effort, you can use ISBSG data. So here you see some subset of the data. I just made a selection of data in the ISBSG dataset. And then you can make your analysis. So in this case, I have selected 151 projects and it has a distribution. And I usually use, for instance, the P25 or P30. This is like percentiles, right? So this means that 30% of all the projects that I've selected in this 151 projects have a PDR, a project delivery rate, hours per function point of 6.7 hours per function point or lower. The median is the middle value and the P70 is the 70% value. And you can have, of course, also the max, the min, the P10. There's a distribution there, and distribution is important because it shows you something also about the spread in the data, which shows you a bit more about also the accuracy or the uncertainty that's there. But you can see here also that if you do this, for instance, I measure with a high level estimation of Nesma some pile of documents, and there's 1,000 function points there. Already when I do this, I can select in the ISBG, okay, I have a Java project, it's about 1,000 function points, and show me the data, and you can already get this, for instance. And then if you have this, you can already estimate, okay, I have 1,000 function points, so probably it's going to be somewhere between 6,700 and 9,400 effort hours. And it gives you a range, and the range already shows you how much confidence you have in your estimate at that point, which is, so this is something you can do already very early in the project, and it's very easy to do. There's not really an issue there. But you can only do it if you have first your size measurement. If you don't do the size, you have to go here. You can't use the ISBSG data or any other data. You just have to rely on your experts and on the people that have an idea about how much effort and cost it should take. So I just showed you a bit of ISBSG data. So how does it look like? So there are actually two different ways of looking at that. This is the Excel sheet, the development and enhancement repository. It has over 11,000 projects here. And basically it's an Excel sheet where every row is a separate project. And you can see here, there's only a few data attributes here, but you can see here there's like 251 columns, and not all of them are always filled in. Sometimes they are just empty. But there's a lot of data about industry sector, organization type, what type of application it is, what type of project it is, and of course important is the project language and the primary program language, because this is a real discriminator. Let's say Java or .NET or Oracle or IBAP or SAP. It's important because this really drives also productivity. Here you can see the accounting approach, you can see functional size, and there is a method in ISBSG also to convert the size to a relative size so that you can easily also select, for instance, I want to in my dataset only large projects or small projects, for instance. And you can see here, these are the standardized methods, right? I talked about that before. We have Nesma, IFPUG, Cosmic, there are a couple of more also there. But these are the main ones that are used a lot in the industry. So many organizations that use functional size can use this data and make their own selections, make their own filtering, and come up with meaningful analysis. And for power users, like myself, I use the data a lot, but other ones also, of course. So you can just slice and dice, make your filters, pivot tables, well, use it just like any other data source, connect to it with APIs, use it in other tools, etc. And for instance here, this is just an example. Okay, you can make your analysis, try to figure out the distribution, and oh, sorry, we have someone in the call. Okay. Then the other thing is the productivity query tool. So this is an online tool that you can subscribe to. And so it's not for power users. You can really, okay, you can do some filtering, but you can't really exclude data from the analysis or remove outliers, those type of stuff. You can fill in a couple of variables. And step 2 is, okay, I select a couple of things more. So I have government, I have program language is Java, and you will get the selection. And you can click the button and it will estimate based on these characteristics. It will estimate your project, hours per function point, number of hours, and the duration. So this can be very useful for, let's say, for management or people that don't use the data often. So if you only use the data once or twice a year and you only want to do high-level analysis, this would be probably the most cost-effective thing for you because it's not very expensive. I think it's maybe only $20 or $30 per month to subscribe to this, while the data itself is a bit more expensive. But if you are using the data, if you want to use the data a lot, so you have to do a lot of cost estimations, a lot of performance measurements of a lot of teams, etc., then the Excel sheet would be a better option. And with both methods, you will select some data set and you will be able to just figure out, okay, where is the data, where does it bring me? I have here your productivity rate. In this case, I took the P25, the P75, and the median. And you can see here, okay, I can use this for my minimum scenario, this for my likely, this for my maximum scenario. That's basically how the ISBSG data can be used. You select a data set, productivity, cost efficiency, delivery speed, defect density, all types of metrics are there. And this is considered to be industry averages or industry data. But in fact, we always say that probably the data in ISBSG data is skewing more towards the best in class because only organizations that are on a, let's say, on a certain maturity level are mature enough to submit data. So only organizations that use functional size, for instance, submit data. And then if you use functional size, you are already on a certain maturity level. And if you collect data of completed projects, then you are even on a higher maturity level. Okay, so here I want to show a couple of practical cases that from my experience. First one is about Agile Value Management. So Agile Value Management sounds like a management buzzword, and it is a bit like that. But you have to imagine that I talk to a lot of CIOs that really struggle with their Agile teams. So they have sometimes they have hundreds of Agile teams. They're self-empowered, self-managing, okay, you can trust them to do good things. But if you want to really manage them, and you need to manage your value creation function, because that's you need to do as management, because that's your IT department should do that. You need to understand what's going on with these hundreds of teams. And the problem is that even in the best teams, they often work with story points, which is not a problem on the team level, but like I said before, it doesn't give you the metrics on a higher level to really manage stuff. And here I just have a very simple example, just to explain this whole concept. What's usually happening, what I see happening in the market, and how I talk to customers. Let's say you have a greenfield new team who is going to develop a new, I don't know, minimal viable product for some very nice new product. You can see in the first sprint, they can really focus on the developing new functionality. So here you see the green block, and this is what you want, because new functionality, it is a proxy for business value, because this is what the product owner says, okay, we should develop this is great, this is going to bring us value. You can see here that the functionality we measure both in story points. So the team will say, okay, this is 100 story points. I have a fixed capacity, let's say 1,000 hours in my team in every sprint, because I have the fixed team, 1,000 hours. I develop 100 story points. 900 of them are new functionality and 100 are tasks, because I have to arrange environments. I have to, well, there are multiple tasks that teams have to do that don't really deliver the functionality. But for functional size measurement, you would, of course, only measure the functionality. You don't measure tasks because these are non-functional. That means that 90% here is new functionality, which is great. But then the next sprint, you have a product owner that says, okay, you built this is great, but I want to have this field in another place. I want also to be able to extract it in Excel, and I want to modify a few things. Okay, I have some extra data attributes that I want to show, etc. So you get modified functionality, which is not bad, and you will get also some code refactoring already, because you have to manage technical debt. So you see here already that the red blocks that don't contribute to the value too much are a bit higher, and that will over time this will become bigger, and your fixed capacity of 1,000 hours, less and less of it will be spent on new functionality, which is the value that you want to create. And if you manage this on story points, because all these things will get your story points, right? So the team will say here, this is 100 story points, this is 100 story points, this is 100 story points, this is 100 story points. So from a predictability point of view, the team is very predictable. They're just sprint after sprint, they're delivering 100 story points. So this is great. But from a management and a company point of view, the 100 story points, here it was 90% functionality, here's only 10% functionality. And this is, of course, what you want. The functionality is what matters to the users and to the business. And this is the main point. If you measure this in function points, then you can manage it, then you understand it, then you can, at some point you say, okay, but now my green blocks are so low. I don't know what's going on here, guys, but we have to do something different. Because this is not going to help us to generate the value that we want for the business. And this is only the visibility that you get once you measure your functionality and so your function points, and not when only use story points. But that's an important, let's say, storyline. And this is something that everybody also in the teams understand and see that this is happening also to them. Even the best teams that try to avoid all this, they are still seeing this. And I work for IDC, so we are a benchmarking company. So we compare things in the market, and we have here a number of team metrics. You see here on the left is productivity, cost efficiency, velocity, project quality, and we benchmark teams and we compare them to the averages. The product metrics we also measure, those are on the right, because of course you need also good quality. But for this webinar, that I'm not going to go too much into that. But of course you can be very productive, but your quality should also be good. Otherwise, still users and business won't be happy. And you have these metrics, right? So you have the hours per function point, the dollars per function point for the cost, function points per month for your delivery speed, velocity, and defects per function point. So and the thing is, this we can only do. Let's say comparing teams to market averages, if you are able to determine the market average. And there is the ISBSG data comes in helpful. For instance, if I have a Java team that's you have a productivity of PDR of 10 hours per function point, maybe they are 20% better than market average, so they're here. But the COBOL team that is doing 10 hours per function point would be somewhere here, because the COBOL usually is much less productive language, and the hours per function point usually much higher for a team. So only if you like normalize your productivity to an index like we do here, you can really compare the low performers against the high performers. Because maybe in absolute terms, the guys that are over here, they are in hours per function point better than the guys are here, but just because the environment and everything is different, yeah, you can make that analysis that they're here and not here. And if you're able to do that for your teams, and this is just a demo environment, I know because I'm not allowed to usually to show all this data of our real customers, but it gives the picture. So if, for instance, I have in the company, I have in this case, I think there are like 12 teams here. You are able to, in this case, I have a productivity index, or your performance against industry averages, and this is 0%. So all the teams that are here above the 0% are performing better than market average, and the guys that are over here are performing worse compared to market averages. And again, so the one team can be a Java team, the other one can be a COBOL team. The other one can be an ABAP team. Doesn't matter, because we are able to determine the market average for those type of teams and then compare their productivity against those averages. And then you can see the trends. And for management, this is very useful, because you understand, okay, I have a couple of guys, teams that are performing very well. Let's just figure out what they're doing, and apparently that works. And we have a couple of teams that need a bit of help to improve. Let's just try to figure out what they're doing, not that these guys are doing, and try to learn, get these guys up and speak, get them to learn from the better performing teams. So it's a starting point for improvement for your organization, for your teams. And then, so this is just one of the practical studies that I did. You can see here 4 different teams in 4 countries, but they're all kind of doing the same work. They're working on a marketing system. So this is a lottery. It's a lottery company that provides a certain lottery service in different countries, and they all have a backend system. A local backend system, and they're working on that. And if you look at the productivity of the teams, you can see, for instance, in Netherlands and Sweden and UK, they're doing better productivity than market average, and Germany is a bit lower. But if you look at the quality, the other effect is there. So the quality is, in this case, the number of function points or defects per function points. And you can see that Germany is doing very well. So even though the productivity is a bit lower, the quality is much better. While Netherlands and UK are okay, not that good, and Sweden is really bad. If you really dive into this, you see that Sweden, in this case, is using Kanban. The other teams are doing Scrum. Sweden is doing Kanban. And it seems that the way that they have organized their process is that they don't care too much about quality. They just build stuff as fast as possible, get it into production, and only then look if there is a defect. Okay, they're going to fix it. So you can imagine that in Sweden, the users of this platform not that happy, because there are like many bugs, many incidents, and doesn't work most of the time. Yeah, so this is basically what I just said. Let's just skip it, because I see we're already running a bit out of time. And so one other case that I want to mention here is the redevelopment of a system of a construction company in the Netherlands. So we had to estimate the cost of the redevelopment because they had an external supplier coming in, and this was fairly new for this construction company, because they usually build everything themselves, but they have an external supplier. And they made their expert judgment, and they wanted us to do an objective third-party cost estimation. Well, first we measured functional size. Then we get into the data. Well, we used also METRI data, but let's say we also used the ISBSG data. And then we'll calculate effort hours and duration, and also the breakdown of activities and the cost. And it's basically like I said before. So first you can measure your size. You have a minimum, your likely, and the maximum number of function points that need to be redeveloped. Then you go into the ISBSG data, and you figure out, okay, which technology do I have? What is the breakdown? The percentage of what I have to make for the front and the back end? What are my PDRs, your productivity rates that from the data sets, your delivery speed? And then it's very easy just to calculate how many effort hours do I expect? What's going to be my duration? And you can just compare this to the supplier. And it was not really a surprise that the supplier was, I think, like 30–40% lower as expected. Right, so the supplier estimate was like 30 or 40% lower than this 70,000. And this is what we always say, because if you are on low estimation maturity, especially in these type of cases, right, where you have an external supplier, and usually these contracts are not fixed price because they're agile, and you can't really do fixed price for agile. So this means they work on a blended rate, and your blended rate, let's say €100 per hour. And then, of course, they don't have a real incentive to be very productive, because they can, if they have to do extra sprints, they will just charge it. Customer will pay for it, and in the end, yeah, they will be paid no matter what is their productivity. So it's in their interest also to estimate it as low as possible, because they know that in practice they will have many. If they need more hours, they will get paid anyway. And then from the data, we know the breakdown of the activities. So here you can see architecture, development, Scrum Master, etc. The percentages. Then you have your rate card of your supplier, and you can calculate the cost, right? So you know, okay, I have here the architecture guys. With these hourly rates, I know I have 70,000 somewhat hours. I know 40% of it should be architecture. So you can calculate how much cost will be the architecture, the development, the test, etc. It's not really that hard to do if you have the data. And the good thing, of course, when you use Agile is that you get feedback after every sprint. So here you see a lot of sprints. And you can see already after a couple of sprints where you are when it comes to functionality, for instance, the green blocks from the block picture I showed before. You can see already here that yeah, you're behind, right? You can still make calculations. Okay, where are we going to end up? We thought it was going to be 35 sprints, but here it shows that after 35 sprints, I'm not going to make my minimal viable product. So maybe already very early in your project, you may be wanting to make decisions on maybe adding people, or maybe even do something about scope to make sure that your plan will work in the end. Oh yeah, so then one other thing, and I'm almost at the end now. So this is basically contracting agile teams. And this is going to be more important, by the way, in the future. The agile teams that are going to be contracted in an output-based way, not on the blended rate that I just said, because yeah, industry is looking for ways to get more output-based contracts. And these are based on function points, so you can't use other output-based measures because there are just no other objective measurement methods to measure the output of agile teams. And you see an example of a rate card. It's not that important, but it just shows that usually this is the way that people are contracted. So okay, I want a senior architect. Yeah, okay, here you have one. He has 133 euros per hour, and you just invoice that guy for the number of hours that he works. So there's no guarantee that on productivity or on quality. And this is something that now the industry wants to, a lot of companies in the industry want to move away from that. In the Netherlands, and there's now an initiative that a standard is going to be made in the next couple of months, where a lot of these type of metrics, function point metrics, but also other metrics are going to be in standard on how to contract agile teams in an output-based way. And yeah, so this is just an example on how you can determine the price per function point based on ISBSG data. For instance, you have a blended rate of €100. You go into the data and you see what is the P25, the median, the maximum. and this is something that I see a lot. Also, we have helped organizations, companies like the big system integrators in the world to win multi-million euro contracts just by doing this type of analysis and providing them with the right euros per function point that they can put into their offer. And even last year, we helped a global system integrator win a contract over 20 other companies. So they were selected over 20 other companies just by doing this analysis in an objective, fact-based way using the data and the function points. Yeah, so I'm coming to my conclusion, and I just want to share a few more things. So ISBSG, like I said in the beginning, we have a lot of not-for-profit organizations and for-profit organizations that are contributing to the organization. You can see here the board members, which are also the gold partners. And if you are in any of these countries, for instance, in Italy, you have Luigi, who is here in the call. I myself in the Netherlands. You have a number of people from the US. You have Masayuki in Japan. You have a couple of people in China, Finland, Spain. So yeah, just reach out to these guys if you are interested in ISBSG and the data maybe. These people are also there just to help you with any questions, or send them to our CEO, who's not here today. It's Paula Holmberg in Australia. Just to show you a bit how you can get the data if you're interested. So there are a couple of different options on the site. You can also first become a Nesma member or any other gold partner member, then you will get some discount. And also I have here a coupon that you can use if you already say, okay, I want to buy it now, go into the site and I get a discount there. Just to conclude this webinar, brief summary of what I was discussing, what I was presenting. So ISBSG, I explained, Nesma, I explained. Functional size measurement, very important step in your any analysis. Don't use Flamingo or story point metrics if you really want to make informed management decisions. And the ISBSG data that I showed is mainly based on that functional size, and you can get it in Excel sheet or in a productivity query tool. The objective metrics that I showed, I basically got into the project delivery rate a bit more than the other ones, but there's a lot of metrics in there that you can use. I showed you a bit about functional size, the green blocks, right? If you remember anything of this presentation and you are working in Agile, just remember the blocks, and that you have to focus on green blocks, not led astray with all the other blocks. And once you do that, you see also in your estimate, you can monitor your estimate, because that's the great thing about Agile. Every sprint you get new data, how many hours were spent and how much functionality was created. And it's very easy to teach the people in the team or the Scrum Master or the product owner how to use, for instance, cosmic functional sizing or Nesma high level or estimated functional sizing. It's really not that hard. It's just a trick that you have to learn, and then you can do it yourself. You can use it also for output-based contracting. Like I explained, there's going to be a standard out, at least in the Netherlands, which is the starting point for an ISO standard, by the way. So it's a Netherlands standard at first, but next year it should become also ISO standard for output-based contracting of Agile teams. And if you want to obtain the data, consider to become also a Nesma member. A membership of Nesma is like $95 or euro per year, and then you get huge discount on all kinds of stuff, including the ISBSG data. But you can also become a member of any other gold partner. So the way this works is that ISBSG, the benefits also to be a gold partner for these organizations is that the gold partners can pass on this benefit of discounts and everything to the members of the member. That's basically what I wanted to share, I think, today. If you are interested in reaching out to me, please connect on LinkedIn. It's always nice. And or send me an email in Nesma or ISBSG account. That's all very good. So, and I know I've been talking for an hour now. Apologies if this is longer than you expected. Anyway, thank you for your attention and for joining this webinar. And yeah, if there are any questions, I think we still have maybe a few minutes to conclude.